Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel, and today's topic of discussion is part winding reduced voltage starters. Our objective is to introduce the part winding reduced voltage starting method. Reduced voltage starting methods reduce inrush current and modify acceleration and starting torque characteristics. This lecture operates under the assumption you've watched the primary resistors, reduced voltage starters, and motor connection diagrams lectures, both available at the Big Bad Tech channel. If you haven't watched these lectures yet, or only dimly recall their contents, please take the time to do so now. As you are no doubt sick of me reminding you, the direct and instantaneous application of full voltage to a motor at standstill produces a tremendous surge of current known as inrush. Although brief, inrush can place an unnecessarily high demand on the electrical distribution network, and industries often pay a financial penalty for such events. Additionally, the abrupt acceleration of a motor at standstill may damage the mechanical linkages, like belts, chains, shafts, gears, and couplings the system uses to manipulate the applied load. It is for this reason reduced voltage starting methods are employed. Reduced voltage starting methods include, but are not limited to, primary resistors, part winding, Y-start delta run, sometimes called a star-delta starter, soft starters, and motor drives. All these methods serve to limit inrush current and limit mechanical stresses to the driven load. Today we'll discuss one of these methods, part winding reduced voltage starters, on an introductory level. After we've discussed timer relays, expect to revisit reduced voltage starters incorporating timers in later lectures. As the title implies, part winding reduced voltage starters use only a portion of the available stator windings when starting a motor. As you'll soon learn, reduced voltage should be in quotes because it's actually a bit of a misnomer. However, the effects are the same. A motor when started in part winding mode experiences less of an inrush and accelerates gently in comparison to a full voltage starter. Part winding reduced voltage starters can only be used for low voltage configurations of dual voltage motors. As you'll recall from the motor connection diagrams lecture, this rules out all 3-lead and 6-lead motors, and all high voltage configurations of 9-lead and 12-lead motors, leaving us 9-lead pre-configured Ys in low voltage configurations, 9-lead pre-configured deltas in low voltage configurations, 12 leads configured as Ys in low voltage configurations, and 12-lead motors configured as deltas in low voltage configurations eligible for this technique. The commonality exhibited by these motors is that they are all dual voltage motors in the low voltage configuration. Dual voltage motors ordinarily have 2 windings per phase. Low voltage configurations ordinarily wire these 2 windings in parallel with one another. Consider a 9 or 12 lead motor in the low voltage Y configuration. Skipping over the gory details of the connection diagrams, ultimately winding A1 is in parallel with winding A2, and similarly, B1 is in parallel with B2, and C1 is in parallel with C2. Each phase of a full voltage motor starter therefore sees the parallel combination of 2 windings. Parallel combinations, if you'll recall, always reduce resistance seen between 2 terminals because a voltage source sees 2 available paths for current. A part winding reduced voltage starter separates the parallel windings. One set of windings only is used to start the motor, and then, after the motor accelerates to an acceptable speed, both sets in parallel are used to run the motor. In start mode, only the start or S contactor closes, and only windings A1, B1, and C1 form a Y configuration. The Y formed by windings A2, B2, and C2 is disconnected and does not allow primary current flow. Each phase therefore sees only one available path for current, and as a result, inrush current is reduced because resistance has increased. As I mentioned earlier, the term reduced voltage is a bit of a misnomer, since the Y formed by the windings A1, B1, and C1 still experiences full voltage in start mode. However, the effects are the same. Inrush current and mechanical stresses to the applied load are reduced in start mode. At a certain point, the motor is accelerated to an acceptable speed, and the second set of windings is connected in parallel. In run mode, both the start or S contactor and run or R contactor are closed. Full voltage is applied to both sets of windings in parallel to a motor already rotating close to nominal speed. Given the motor is not at a standstill, inrush current occurs. However, it is again substantially less than if the motor was in locked rotor conditions. Note the part winding reduced voltage starter method utilizes two contactors, start and run, and two overloads, OLS and OLR. Primary current in run mode is essentially divided between two paths. The contactors and overloads must be rated and set for the set of windings they serve. Finally, note that the start and run winding sets must be connected such that they produce the same rotational direction of the rotating magnetic field. Failure to follow the motor connection diagram judiciously could result in a configuration in which the start and run winding sets produce equal yet opposite rotating magnetic fields. This is bad and to be avoided at all costs. Part winding reduced voltage starters needn't be limited to Y configurations. Consider a 9 or 12 lead motor configured as a low voltage delta. Low voltage configurations ordinarily place the windings in parallel with one another, such that winding A1 is in parallel with A2, and similarly, B1 and B2, C1 and C2. A part winding reduced voltage starter would make use of only one set of windings for start mode and both sets of windings in parallel for run mode.